Hi everybody and welcome to Pankaj's Echelon Tutorials. As you can see on the screen, this today's session is for IGCSE Physics and the code of the paper is 0625. And in this today's session, we are going to start with chapter number 14. The name of the chapter is Properties of Waves. Okay, and I'm referring to the Davidson Physics course book. Okay, so let us get started. So in this chapter, first let me put up what we are going to study in a nutshell. Okay, so in a nutshell, you are going to study stepwise the following things. Okay, so let me put up in the nutshell. So in the nutshell, in this order, you are going to study these things with me. Okay, so number one uh, is something about the waves. Okay, what are waves that you are going to study? Waves and its description. Okay, that is what we are going to study about the waves. Then second thing that you are going to study is the different terms and terminology of a wave. Okay, and next you will be coming to different types of waves. Okay, or now the order can be slightly changed, but types of waves will be the next thing. And next will be coming certain numericals. Okay, and then we'll be coming to something called wave fronts. Okay, and the ripple tank. Okay, and lastly we'll be studying some light phenomenon with the help of this wave behavior. Okay, so I think this is going to cover our topic of this chapter number 14, that is properties of waves. Okay, so as I told you, we'll be starting with the wave and its description. Okay, so the wave ka meaning is what, in the physics field of physics, the wave is taken as a model, okay, to explain the behavior of various signals or various phenomenon like light, sound, and electromagnetic radiation, because these are the these are the energies which travel in the form of wave. So let me tell you, wave is a model. Okay, it is just a model. Okay, it is used for understanding the behavior of energies. Okay, now if you see this clip of mine, here it is written that physicists use waves as a model to explain the behavior of light, sound, and the other phenomenon. Okay, waves are what we see on the sea or the lake. Okay, but physicists have a more specialized idea of a wave. Okay, so this physicist or the scientist, they take wave as a model. What we see as a wave is a wave in a sea or a wave in a lake or a water body. Okay, or in a water tank. Okay, ripples kind of a thing. Those are waves. Okay, but from the scientist point of view, these waves are taken as a model. And why it is taken as a model? Because most of the electromagnetic waves or the electromagnetic energies like light, and then even sound being not electromagnetic, but sound is something which can be understood to be traveling in the form of a wave. Light can be understood to be traveling in the form of a wave, and that is why wave becomes very important from the physics point of view. Okay, so that's the importance of waves, right? Now next that I want to come to is these waves can be studied, or the behavior of the waves or the shape of the waves and all that, can be studied very well with the help of something called a ripple tank. Okay, so what is a ripple tank? That is the next thing. Okay, so next I come to what is a ripple tank. Okay, now ripple tank happens to be a small, not a very small, but a very comfortable table sort of thing. Okay, now you can see this pic. Okay, this is the pic of a ripple tank that I have shown here. Okay, let me bring it in the center. Yeah, let me slightly make it bigger also. Okay, so you can see that this is a ripple tank. This is also something we are going to use. This is also something we are going to use now. Okay. So first of all, what is a ripple tank? So if you can see this clip of mine, this is going to explain you what is a ripple tank. Okay, right. Now ripple tank is uh, this is a diagram of a ripple tank. Okay, and in physics a ripple tank is a shallow glass tank. Okay, so basically it's a glass tank. So what is a ripple tank? It is a glass tank. That's important. Okay, it's a glass tank of water used to demonstrate the basic properties of waves. So the basic properties of waves are what? The wavelength of the wave, the frequency of the wave, and the peaks of the wave, the throw of the wave, etc., etc. Okay, these are the basic properties of a wave. Okay, and the speed of the wave. These are the basic properties. So the basic properties of the waves. Okay, if you want to demonstrate or if you want to understand them, then for that a tank, a shallow tank, a tank containing water, a glass tank is taken, and this particular tank is nothing but a ripple tank. Okay, now it is a specialized type of a water tank, and the ripple, okay, tank is usually illuminated from above. This lamp, can you see this lamp? This lamp sort of things are used, okay, to illuminate the water tank. This is a lamp, right? This is that glass ka water tank. Okay, and it contains water, right? So this water tank is illuminated with some lamp sort of thing. Okay, so that the light, okay, the light of the lamp, falls on the water, and it shows through at the bottom. Okay, so illuminated from above, so that the light shows through the water. Okay, or shines through the water rather. Okay, it is shines through the water. Fine. Okay, so that is all about a ripple tank. So if they ask you what is the definition of a ripple tank, this is the definition of a ripple tank. Okay, and here you can see a ripple tank. So it's a elevated, it's kept on an elevated table, because you have to keep a screen over here. So this is a screen. Can you see this? This is a screen. Okay, now this is a table, and this is that tray of the tank, or you can say a tank. Okay, you can call it tank or a tray. Okay, now this particular tank, okay, it is made up of glass, so it is transparent, and it contains water. Okay, now along with water, you can see this arrangement over here. Can you see this stand? On this stand, you know this is this thing, you can see this. Okay, this is an oscillating pedal. Okay, so there are two types of oscillating pedal. One is like a bar, a horizontal bar. Okay, another is like a spherical dipper. Okay, so this is that horizontal bar that I'm talking about. Okay, so this is a bar, and it keeps on oscillating up and down with the help of this motor, okay, which runs on the power supply. And there's another type of arrangement also, which is known as a spherical. Now this is a bar, this is a spherical, you can say oscillating pedal, okay, but it is spherical in shape, okay. This can also be used to create ripples, okay. So this bar and this spherical object, can be used to create ripples, okay. And obviously they are going to create different types of ripples, okay. Now what is a ripple? I'll be coming to that also. So can you see this horizontal bar? That is nothing but a oscillating pedal, okay. It will oscillate up and down with the help of this motor which runs on a power supply. Fine. Now once that happens, once this vibration starts, okay, ripples will be created in the water. Okay, now what is a ripple? Ripple is nothing but a wave. So what is a ripple? Ripple is nothing but a wave. Ripple, it is a wave. Okay, so ripple is nothing but a wave. And on the screen below, because of this lamp, on the screen below, you will be able to see certain ripples. Okay, and these ripples will be moving from left to right. Okay, so these are the ripples. It will be bands of you know dark and alternate dark and light bands, which will be moving from left to the right direction. To be precise, let me show you a ripple over here. Now this is the diagram of a ripple. Okay, this kind of ripple you will be seeing over here on the screen. Okay, so this is a ripple. Now this is a ripple which you will see when you are using a oscillating pedal, which is of the form of a rectangular bar. Okay, this kind of ripple. And when you are using this spherical this thing pedal, okay, now can you see here, this is that spherical pedal that I was talking about. Let me enlarge this. Yeah, can you see this is that spherical pedal, okay. Now when this is vibrating up and down, okay, it is creating a different kind of a ripple, okay. So that ripple is shown over here. Can you see this? This is that ripple, the second diagram, okay. So this is known as a straight ripple, and this is known as a circular ripple, okay. So basically there are two types of ripple: circular and straight, okay. So this ripple formation will help you a lot in understanding the behavior of a wave, and this ripple formation can be obtained with the help of something called ripple tank, okay. So as far as ripple tank is concerned, this is the importance of ripple tank, and lots and lots of properties of these waves can be understood and can be examined with the help of a ripple tank, okay. You can observe the ripples, and you can analyze the ripples, and you can find out so many things, right? So that's all about ripple tank. Next in the order will come to the different terms and terminology which are involved with the waves, okay. So let us come to that now. On the screen you can see now, there are certain wave formation that I have shown you on the slides, okay, and some terms and terminology that we are going to study now, okay. So let us start with the very first kind of the wave. Just pay attention to this particular diagram, okay. Now can you see this is a wave formation, okay. Now let us first try to understand what are the various terms and terminology which are associated with a wave, okay. So as you can see, this is a wave, okay, and or you can say this is the representation of a wave, okay. Now this wave, has this particular point which is known as the highest peak, okay. So this highest peak is something which is known as a crest. So in my terms, okay, the first thing that comes is a crest. And what is a crest? Crest is a highest peak of a wave. Can you see? This is a crest. Okay. Second in order comes is something called a trough. Okay. Now what is a trough? Trough is the lowest peak. Okay. It is the lowest peak. Okay. Of a wave. So can you see this is a trough? Now normally this crest and troughs are represented by capital C and capital T. Okay. Fine. Next is something called a wavelength. Now what is this wavelength? Okay. Now wavelength, according to the definition, wavelength is the distance between two consecutive crests. Now see, these are crests. Okay. This is C1, this is C2, this is C3. These are the three crests. So the distance between any two consecutive crests, for example, between C1 and C2 or between C2 and C3, okay, this can be called as a wavelength. Wavelength is nothing but a certain length. Okay, so wavelength is the third term that you should understand. Wavelength is denoted by a lambda. Okay, wavelength is denoted by a Greek alphabet lambda. Okay, and the definition is over here, right? Now if you want, I can bring this definition to your view over here. I'll slightly zoom it. Yeah, I think that should be okay. Right, now this is the definition of a wavelength. Okay, so if you see the definition of the wavelength, it says that wavelength, which is represented by this lambda. Okay, now this is lambda. Lambda is the this Greek alphabet that I was talking about, this one. Okay, so distance between two crests or the distance between two trough is known as wavelength. That this is one of the definition. Or you can say the distance between two consecutive particles which are in phase. Okay, and what is the meaning of this particles in phase means? Suppose a particle is over here at this point. Okay, can you see this point? Let me mark this point as say A. Okay, and this point is say B. Okay, so the distance between two consecutive particles which are in phase. Now this A and B are said to be in phase. Okay, this A and B are said to be in phase. Now this distance is also known as the lambda or the wavelength, you can say. Okay, this distance AB is also nothing but wavelength. Okay, even this B and C are again in phase. Okay, now this particles in phase, this is not included in your syllabus so far. So let us not talk much about that definition which is involving this phase term. Okay, this phase is something which is not there in your book. It is nowhere mentioned so far, but it will be coming in future, maybe when you study physics at a still higher level. But right now this phase is something which you should not worry about. So I think this definition will be enough, that is the distance between the two crests or the distance between the two trough. Now whether it is two crest or two trough, it is the same distance. Okay, so this distance is between two consecutive crest or two consecutive trough are known as the wavelength of a wave. Okay, so I think that wavelength part is done. Okay, now next term that comes, and the this thing, the unit of this wavelength will always be the unit of any length. Okay, so if it's a big wavelength, okay, the unit can go in terms of meters also. Okay, and if it is a small, it can go in terms of centimeter, millimeter. But if there are these electromagnetic waves, the unit used is Armstrong unit. Okay, it is written in this way, right? Armstrong unit, right? So that is wavelength. Now coming to the fourth point, that is the frequency. Okay, now what is this frequency? Okay, these are the terms that we are dealing with. Frequency is something which is denoted by a small letter f. Okay, now if you see this particular diagram, okay, you will see again a wave over here. Okay, and let me tell you, a wave is consisting of a crest and a following throw. Okay, so suppose a wave starts from here, that is point A. Okay, this is the first crest, C1, and after that crest, sorry, this is the first throw, T1, and after that you have a first crest, that is C1. Okay, and then the wave comes back to this particular position, that is in phase. Okay, so this is point A and this is point B, which is again in phase with point A. In phase means at the same level, horizontal level. Okay, so a single wave can be considered as the path covered from A to T1 and then to C1 and then again to B. Okay, so this path covered by the wave is taken as a single wave. So if you want to count a wave, okay, you will have to count it in this way only. Starting from A, you either go down to a throw, then to a crest, and then come back to the same level as A and stop here. That is one single wave. Okay, or it is also known as one single cycle. Okay, it is also known as cycle or a wave. This is also known as one frequency. Okay, so one wave is equal to one frequency, two wave, two frequency, three wave, three frequency. Okay, but when you use the word frequency, it should be associated with 1 second. So what is frequency? Frequency is the number of waves, okay, made in 1 second. Simple as that. In 1 second, if the number of waves created or made are say 10, then you will say that the frequency is 10. 10 hertz. Okay, you will say 10 hertz. The unit of this frequency is hertz, Hz. Okay, so whatever is the number of waves created or made in 1 second, that you will have to take as the frequency. Is that clear? So I hope frequency is also clear to you, and I'll just show you the frequency ka definition here. Okay. Okay. Uh, yeah, I think it's clear to you. Frequency. Okay. So what frequency is? Let us see here. The definition is there on the slide over here. Frequency. It is denoted by a small f. The number of waves generated in 1 second, or the number of waves passing one particular point in 1 second, is known as a frequency. Okay, and the unit of frequency is hertz, Hertz, and the symbol for that hertz is a capital H followed by a small z. Is that clear? Now if you see these two waves, here in the top you can see that the frequency is less, and here at the bottom there's another wave whose frequency is more. Okay, how we can say that? Suppose I take this point. Okay, uh, okay, suppose this is the starting point. Okay, so from here to here there will be one wave. Okay, this is one wave. Okay, then from here to here, so this is one. Then when I reach here, this happens to be 2, this is 3, this is 4. Okay, and when I come here, this is 5. So I can see that there are 5 waves over here. Okay, okay, 5 complete waves. So and suppose this happens in 1 second. Okay, this is produced in 1 second, then my frequency will be 5 hertz, because there are 5 waves that I can see. Now suppose this at the bottom, the wave which is shown, that also is made in 1 second. Okay, but here let us count how many waves are there. So starting from here, this will be 1. Okay, this is 1. Let me use this red pen. Okay, so from here this is 1. Okay, then this is 2, this is 3. Okay, I'm counting the complete waves. This is 4, and here I'm getting a 5, but the wave is continuing to come here, and this is 6, this is 7, this is 8. Okay, and this is 8, and this is 9, and here when you come it is 10. Okay, so in the bottom the wave is having 10 hertz frequency, this is having 5 hertz frequency. Okay, So if you want, I will just zoom it. Fine. I think you will be having a clear view about it. Okay. Now, this is a wave which is having 5 frequency. This is a wave which is having 10 frequency, the double. Okay. So that's the frequency card definition. That's the meaning of frequency. Okay. So I hope this is clear to you. So let us move on to the next term, and that next term is nothing but a time period. Okay. So let us come to that. So coming to time period, just remove all this. Okay. The next term in the order is time period. Okay. Fifth one is time period. This time period is denoted by a capital T. Okay. What is this time period? Time period is now you can see this diagram. Okay. Here I have shown a wave. Okay. And on the x-axis I have taken this time. Okay. So this x-axis is showing me the time. So the time period is nothing but the time taken by a single wave. Okay. So in seconds, right? So suppose this wave, it starts from this point O, and when it is completed, it comes to this point A. So OA is the journey of a single wave, right? So suppose the time taken for this single wave, the time here at the point O, suppose the time t is say 0.5 seconds, then you say that the period or the periodic time of this wave is 0.5 seconds. Okay, so that is known as uh, periodic time t, capital T. Okay, now suppose there are many waves. Okay, so now in this case it is one, and then there's another one, two. Now suppose these two waves take, say, now this is point C. At this point suppose your t is equal to 1 second. Okay, so here you can say that two waves, one and then the second, two waves are taking how much time? 1 second. Okay, so two waves takes 1 second. Okay, so what is time period? Time period is the time taken for one wave to be formed. So when two waves take 1 second for formation, one wave will take how much time? Obviously it will take half second or 0.5 second. So that 0.5 second is nothing but the time period. Okay, so what is time period? You must have understood now. Time period is the time, let me write that for you. Time period is the time in seconds, okay, for obtaining one wave. Okay, just a single wave. Okay, and last but not the least, since we have understood all the terms now, okay, we'll come to the next term. And before coming to the next term, let me tell you there's a relationship between this frequency and the time period. Okay, and that relationship is the time period is reciprocal of frequency. Okay, time period is always reciprocal of frequency. If you see the definition also, it will be very clear to you that time period and frequency both are inverse of each other, reciprocal of each other. Okay, so if you see this particular diagram over here, okay, this one, this is telling you that the period and the time, okay, sorry, the time period and the frequency are reciprocal of each other. Is that clear? So this particular relationship is always there. Okay, so frequency is 1 upon t, or t is 1 upon f. So somebody, if they say that the frequency is 5, then the time period will be 1 upon 5 seconds. Okay, simple as that. Okay, so remember this. And last but not the least, the speed or the velocity of a wave. Okay, this is the last term that you should understand. Now what is the velocity of a wave? Velocity of a wave is nothing but its wavelength divided by the periodic time. Now why this is the formula for velocity of a wave, okay, the speed, you know, in general physics, speed is equal to distance upon time, distance traveled upon the corresponding time taken, okay, or you can say speed is equal to distance traveled per unit time, isn't it? So the speed of a wave correspondingly is nothing but the uh, wavelength divided by the periodic time. Why? Because this wavelength is nothing but the distance traveled by the wave, and this periodic time is nothing but the time taken for a single wave, so unit time, okay. So this definition and this definition are one and the same. So velocity of the wave can be found out with the help of this particular formula, that is v is equal to lambda upon t, and if you arrange this, okay, you can get the another formula also, v is equal to lambda times, now t can be replaced by this 1 by f, okay. So I can write, instead of t I can write 1 by f, and I can rearrange this f and I can bring it on the top, so it will be lambda into f. So I get another formula which is v is equal to lambda times f, okay, lambda times f. So this is also a formula for the speed of the wave. So speed of the wave ka meaning is what? The speed of the wave means the speed with which the energy is carried by a wave, okay. Now just now I used a word energy being carried by a wave. So a very important aspect of a wave that I'm going to talk about before ending this today's session is this one. Okay. A wave, the complete meaning of a wave is now this. Okay. So wave is, it is a model, okay, and of a signal. Okay, now this signal can be sound signal, light signal, anything, okay. So it is a model of a sound or a light signal or any other electromagnetic signal, okay. And this wave is created, okay, or obtained by a vibrating particle, okay. So any particle which is vibrating, okay, will always create a wave, okay. And this particular vibrating particle, when it creates a wave, you know what happens, the particle will be vibrating, okay, in one plane only, a vibrating particle in one plane, okay. And the energy is moving along the wave, okay. The energy will be moving along the wave, uh, and no matter is moving, okay. These are very important aspect of a wave. So whenever you think of a wave, okay, now this is a wave, you can think of a particle which is vibrating up and down in a single plane. So this is a particle vibrating, okay, particle vibrating. So particle will be vibrating in a up and down direction, that is in a single plane. This particle is not going to go right and left, okay, but the wave is going to move either in the right or the left direction, okay. Wave is going to move. So what is moving is not the particle, okay. So we say that the matter is not moving, okay, matter is not moving, right. So what is moving? The energy is moving. So in a wave, to summarize everything, and today's session, we can end up with this important point, that in a wave, okay, the matter doesn't move, okay, but the energy is something which is moving, okay. So in any wave, it is the particle is vibrating in only one particular plane, it is not leaving its position, so it is not moving. So matter is not moving, but the energy is moving from right to left. So energy of this vibrating particle will be transmitted to the neighboring particle, and it will start again oscillating up and down in its own one plane, and that particle will again create energy which will be transferred to the further particles, and that is how the energy is something which moves along the wave, but the molecules will be just dancing up and down. Okay, or the particle will be just dancing up and down. Now this is the reason when you happen to see that in the sea, if there is a wave formation, okay, in the sea, and if you happen to see, if you happen to put a cork on the wave, okay, or if you happen to see a bird sitting on that wave, this bird will not be moving from left to right along with the wave. Okay, it will be moving up and down, or the cork will be moving up and down. Although the wave is moving from left to right, you will always see that particular object like a cork or a bird, it is just moving up and down. It is not moving either to the right or to the left. Okay, so I think in this today's session I tried to cover up what is a wave, what is the meaning of a wave, what way ripple tank can be uh, helpful, and ripple tank will be coming back to that in the coming videos. Okay, and we'll be studying the various aspects of the wave using a ripple tank. That will be revisiting ripple tank obviously. And today's session I was trying to dedicate more on the different terms and terminology which are related to these waves, and those were explained by me to you. And in the next video I'll be coming up with this relationship between all these terms that we have come to, and of course the relationship is the last point we have discussed that also, that is v is equal to lambda into f. So this is one relationship, and another relationship is this one. Okay, t is equal to 1 upon f. So these are the two relationship that were observed, okay, between these terms that we have discussed today. Okay, so in the next video perhaps I'll be starting with the numericals connected with this topic that we have studied now today. So till then, goodbye, take care all of you.